Hey, today we're going to talk about 8.14, pollution and human health. So before we begin, you can check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So today we're going to be talking about pollutants that can affect human health, and then the next video will be about pathogens that can affect human health. But today we're going to start with something that I used to play back when I was in high school. There was this game on the old-timey computers called Oregon Trail, and it was simulating the journey that people took out west, and you had to buy supplies, and then it was like, it went really slow. Anyway, it was the most exciting game we had to play at school because it was educational. Anyway, people always died of dysentery. And dysentery is a illness that is caused by eating food that is contaminated with fecal matter. And dysentery results in, I know this is the cleanest way of putting it, but it results in bloody feces and extreme diarrhea that results in dehydration. So when people die of dysentery, they're dying of dehydration that is brought on by the extreme diarrhea. And there is blood also in the feces. So the only way to, well, it's a preventable illness because the best way is to drink and consume water and food products that haven't been contaminated with fecal matter. Seems simple enough. This is common in developing countries because of the sewage treatment, and the water treatment is not as advanced as it would be in a developed country. Mesothelioma is a disease that is caused by asbestos, and it's when there are tumors that form inside your lung and your tissues in the cavities inside. And you've probably seen commercials that are like all these like lawyers on TV that are talking about are you exposed to asbestos, mesothelioma? A lot of especially around September 11th, a lot of people that were cleaning up the World Trade Center at Ground Zero after 9/11 developed mesothelioma long after, or months to years after they were exposed. And it's still something that exists. Remember that asbestos is found in insulation systems. It's very effective, but once it becomes dislodged, it becomes airborne and it can get into your lungs. And the very fine particles can break off and become even smaller and get wedged in deeper into your lungs and other tissues in your respiratory tract, and eventually can cause cancer. And this actually was taken, I took this down the street from my house. This is in Greenpoint, but they were demolishing this building, and they started to tear it down, and then I noticed that everybody was wearing hazmat suits. You can't really see it here, but everyone was wearing a hazmat suit, the PVC all over them, whatever, the Tyvek. And I saw this sign that said Notice of Asbestos Abatement. This means that they're getting rid of the asbestos. So these are professionals that are skilled in removing asbestos. And what you need to do is make sure that you seal off a particular room if you're removing the asbestos, and make sure the ventilation in that room is adequate. So other respiratory disorders can be developed from incineration, and that was when you release particulate matter, or you can also have asthma can be exacerbated or made worse by the release of pollutants. Again, tropospheric ozone is another cause of respiratory disorders. It's a very strong oxidant, and it can damage the DNA in your respiratory system, so it can lead to, eventually if it damages your DNA, it could lead to cancer, but for all intents and purposes, it's really a strong oxidant. I don't think that the levels that we would breathe in the tropospheric ozone are strong enough to damage our DNA, but it can damage the DNA in plant tissues when it gets into the stomata. Now there is this concept of synergism, and synergism, remember SYN, means together. So I'm going to tell you an analogy and then I'm going to explain it. But an analogy is, imagine you had all these boxes to move, and you're moving the boxes by yourself. It's going to take a long time to move them. But if you had two people moving the boxes, the effect of having two people is actually going to have a greater effect than the amount of time it takes one person. If you had two people, it's not like taking the time you did it by yourself and then divide it by half because you got two people. You're actually going to be going a lot faster. So the impact of increasing something or having two things together is actually greater than the impact of just one of them or the sum of them put together. Does that really make sense? Let me explain. So if I have chemical A and this fish consumes chemical A, fish is fine. They consume chemical B, the fish is fine. All of a sudden, they consume chemical A and chemical B. Something happens to the fish, it dies. So this is a problem, and this is an example of synergism, where the effects of chemical A plus chemical B is far greater than the effect of chemical A or chemical B by themselves. So what does this look like in real life? Some real life examples. Well, if you have asthma that was brought on by air pollutants and you get COVID-19, the effect of both of those together could be fatal. The COVID-19 might not be fatal, but when you have this underlying condition, it can become fatal. Another example is if you have lung damage from smoking, and then you also get exposure to asbestos, you'll have a much greater chance of developing lung cancer than from either one of these two actions separately. Okay, for FRQ practice, I would like you to look at this diagram. and this is basically showing a river with different human activities. So based on the diagram to the left, which shows various activities along the course of a river, make a claim which location, A through D, would likely have a higher probability of dysentery infections. Justify your response with information from the diagram. So I hope that this video was informative. I thank you for your attention, and I will see you soon.